Hello friends, welcome to the series of lectures of Mathematics 1. Now up in today's session, we are starting with the unit System of Linear Equations and Matrices. Now the today's topic we are going to cover is a row echelon form and the reduced row echelon form. Now first of all, what is a row echelon form? A matrix capital A is said to be in a row echelon form if it satisfies these three conditions. First condition, if there are any rows consisting entirely of zeros, then they are grouped together at the bottom of a matrix. That means the row consisting only zero elements, and if you have whatever the number of rows you have, they all must be at the bottom of the matrix. Second condition, if a row does not consist entirely of zeros, then the first non-zero element in that row is 1 and we say it a leading one. That means each non-zero row, in that the first non-zero element must be 1 and we are going to say it is a leading one. See, in some of the books, there is the leading one is must not be 1. There it may happen, it may have a non-unit value. That means it may be 1 or it may not be 1. Then also we are going to say it a leading one or a pivot, leading element or a pivot element. In that case, we are not going to say it as a leading one. Here we are defining it in a form of leading one. Third case, if in any two successive rows, non-zero rows, the leading one in a lower row is further to the right than the leading one in upper row. That means the leading one in a lower row is right than the leading one in a upper row. Okay. If these three conditions are satisfied, then whatever the matrix we have is said to be in a row echelon form. Here we have written 2 examples. First one is the 1 1 0, then 0 1 0 and 0 0 0. See here, the last row is a zero row. That is the first condition. Zero rows, if there is any zero row, then it must be at a bottom. Then second condition, each non-zero row has a first non-zero element 1. So in first row, first element is directly 1. But in second row, first element is 0. And then second element is 1. So whatever the first non-zero element we have, that must be 1. It is not necessary. Zero element is not going to be considered. So this second condition is also satisfied. First non-zero element in each row is 1. And the third condition, leading one in a lower row is further to the right than the leading one in a upper row. Okay. So second row has a leading one to the right than the leading one in a first row. So third condition is also satisfied. Therefore, the first matrix is in a row echelon form. Same manner, second one, there is no zero rows. Okay, each row is non-zero. So first condition is automatically satisfied. And second condition, each first non-zero element is 1. Check out. And third condition is also satisfied. The second row has a leading one to the right than the first row. Same manner, third row has a leading one to the right than the second row. Same manner, in third one, zero rows are not there. Each first row has a first non-zero element 1. And see, it is not necessary your leading one is only one step right to the leading one in upper row. It may have a 2-step or 3-step right. So check out the second and third row. So in third row, the leading one in the last row is right, two step right than the leading one in a upper row. Okay. So this is the basic concept of a row echelon. In a reduced row echelon, first three conditions are remaining same. That means if there are any rows consisting entirely of zeros, then they are grouped together at the bottom of a matrix. That is the first condition. Second one, if a row does not consisting entirely of zeros, then the first non-zero element must be 1 and we are going to say is that leading one. Third condition, in two successive row, the leading one in the lower row is further to the right than the leading one in upper row. And the fourth condition, each column that contains a leading one has a elsewhere in that column. Okay, that means except leading element 1, all the entries other than leading 1 in that column must be 0. All the entries of that column other than leading 1 must be 0. This is the extra condition for a reduced row echelon form. Okay, and if these four conditions are satisfied, then the given matrix is said to be a in a reduced row echelon form. Here example we have written. See, the first example is a 0 0 0 0. See, 0 rows are always going to be satisfied all condition because there is no leading one. So first condition 0 rows at the bottom of a matrix. Second one, if non-zero element is there, then the first element must be 1. Here there is no leading one. Same manner, third one, leading one in the lower is further to the right than the leading one. That is also going to be satisfied. And fourth condition is automatically satisfied because there is no leading one. So each column contains 0 and therefore fourth condition is automatically satisfied. So this 0 0 0 0 matrix is in a reduced row echelon form. We are shortly we are going to say it is RRE form and row echelon is RE form. Okay, please remember it. Same manner your identity matrix 1 0 0 0 1 0 and 0 0 1. See, there is no zero row. Secondly, each row has a first non-zero element 1. Thirdly, the leading one in the lower row is further to the right than the leading one in the upper row. These three conditions are already satisfied. Fourth condition, now the column of leading one. In the column of leading one, all entries other than leading one are 0. Okay, so check out it. Now same manner third one and fourth one. It is not necessary other than leading one. If you have any entry, then in that column entries may or may not be 0. But in the column of leading one, all entries other than leading one must be 0. Okay. Now we are going on to the example. In each part, determine whether the given matrix is in a row echelon form or reduced row echelon form, or both or neither. See, the first matrix we have is a 4 by 5 matrix. Okay, 4 rows, 5 columns are there. First row is 1, 2, 0, 3, 0. Second row is 0, 0, 1, 1, 0. Third row is 0, 0, 0, 0, 1. And last row is 0, 0, 0, 0. See, first condition of row echelon is 0 rows at the bottom. It is already there. Second condition, each row has a first non-zero element 1, correct? So it is each row has a first non-zero element 1. Non-zero row has a first non-zero element 1. And third condition, the leading one in the first row, second row is further to the right than the leading one in the first row. That is satisfied. Same when the leading one in the third row is further to the right than the leading one in the second row. That is also satisfied. That means all conditions of row echelon are satisfied. Now for reduced row echelon. Now in a column of leading one, the first column it contains the leading one, and in that column all entries other than 1 are 0. Same when the third column contains the leading one and all entries other than leading one are 0. Same when the last fifth column contains the leading one and in that also all the entries other than leading one are 0. So the given matrix is in a reduced row echelon form. Okay. Second matrix we have written is again a 4 by 5 matrix. And here your matrix is 1, 3, 0, 2, 0, then 1, 0, 2, 2, 0, then 0, 0, 0, 0, 1, and last one is 0, 0, 0, 0, 0. Okay, so if you are going to check out 0 rows are at the bottom. Second condition, each non-zero row has a first non-zero element 1, that is also satisfied. But the third condition, the leading one in the second row must be to the right than the leading one in the upper row. That is not satisfied. Okay, and that's why your condition is not satisfied. Third condition, that's why this matrix is not in a row echelon form. And if it is not in a row echelon form, that means it is not in a reduced row echelon form also. That means it is neither row echelon nor reduced row echelon. Third matrix you have given is 1, minus 6, 4, 3. And second row is 0, 1, 3, 2. Correct? This is your 2 by 4 matrix. And since Zero rows are not there, so first condition satisfied. Each row has a first non-zero element, one. That means second row is second condition is also satisfied, and the leading one in second row is further to the right than the leading one in upper row. That's why it is going to be reduced row echelon form. Now, in the second column, leading one is there as well as -6 is there. That's why the column contains non-zero element other than the leading one. That means this matrix is in a row echelon form, but not in a reduced row echelon form. Okay? And the last matrix, in that one, first condition is not true because second row is a zero row and it must be at the bottom of the matrix. But it is not at the bottom. That means that matrix is neither in a row echelon form nor in a reduced row echelon form. Okay. Now find the row echelon form of the matrix. We have given 4 by 4 matrix. First row is a 0, -1, 2, 3. Second row is a 2, 3, 4, 5. Third row is a 1, 3, -1, 2. And fourth row is a 3, 2, 4, 1. Correct? Now we are starting with original matrix. And first we need first non-zero element as a 1. So what we are going to check out? We are going to check out the column of first one, and in first column there is a entry 1. That's why we are going to starting with a interchanging the row. So interchanging the row first and third, that means R1 3, and that will give you third row will be the first row and first row will be the third row. So your matrix is going to be of the form 1 3 -1 2, 2 3 4 5, 0 -1 2 3, and third last one is 3 2 4 1. Correct? Now, once you have the first non-zero element 1, then if you have to make the row echelon form, then all the entries below leading one must be 0. That means what we are going to do, all the entries below in the leading one, we are going to make them 0 by the basic row operations. So what we are going to do, we are going to write down R2 minus 2R1 and R4 minus 3R1. So that will give you the matrix 1 3 -1 2. Second row is going to be 0 -3 6 1. Third row will be 0 -1 2 -3, and the last row will be 0 -7 7 -5. Now we are going to interchange the second and third row. See why? Because second row has the first non-zero element -3, third row has the first non-zero element -1. So we are going to interchange them, and then we are going to multiply the second row by -1. That will give you the form 1 3 -1 2. Second row is 0 1 -2 -3. Third row will be 0 -3 6 1, and fourth row will be 0 -7 7 -5. Now all the entries below leading one must be 0. So we are starting with the second row and making third and fourth row second element 0. That for that we are going to use the operation R3 plus 3R2 and R4 plus 7R2. And your matrix is going to be reduced in a form of 1 3 -1 2, 0 1 -2 -3, 0 0 0 -8, and 0 0 -7 -26. Now interchange third and fourth row, because see, in a third row last element is non-zero, in a fourth row third element is non-zero. So we have to find out whether third column has a leading one or not. For that we are going to interchange it. Now multiply third row by -1 by 7, and that will give you the matrix 1 3 -1 2, then 0 1 -2 -3, then 0 0 1 minus plus 26 by 7, and last row will be 0 0 0 -8. Again, for a last row we are going to make last element 1, so we are dividing it by -8. So last row will be a 0 0 0 1. Okay, so that will give you your row echelon form. Now find the reduced row echelon form of a following matrix. A matrix is 4 by 4 matrix, and the value is 1 2 -3 1, -1 0 3 4, 0 1 2 -1, and 2 3 0 -3. Okay. Starting with the solution, again here already first non-zero element is already 1. Okay, so there is no need to interchange the row. Now all entries below the leading one must be 0. Here we have to reduce in a reduced row echelon form. That means all entries below and above leading one must be 0. So first we are starting with a first row. Using first row we are going to make first three elements of a second, third and fourth row 0. So using the operation R2 plus R1 and R4 minus 2 R1. See, that will give you the matrix 1, 2, minus 3, 1. Second row will be a 0, 2, 0, 5. Third row will be a 0, 1, 2, minus 1. Fourth row will be a 0, minus 1, 6, minus 5. Same manner. Now interchanging second and third row, because third row has a leading element 1. So interchanging it, that will give you 1, 2, minus 3, 1. Then second row will be 0, 1, minus 2, sorry, 0, 1, 2, minus 1. Third row will be 0, 2, 0, 5. And fourth row will be a 0, minus 1, 6, minus 6, minus 5. Okay. Now again, all the entries below and above leading one must be 0. So for that we are going to use second row to make all the entries other than the leading one 0. So what we are going to do is, we are going to use the operation R3 minus 2 R2 plus and R2 plus R4. Sorry, R4 plus R2. And that will give you 1, 2, minus 3, 1. Second row operation will be, second row will be 0, 1, 2, minus 1. Third row will be 0, 0, minus 4, 7. And fourth row will be 0, 0, 8, minus 6. Now, dividing third row by minus 4. And that will give you 1, 2, minus 3, 1. 0, 1, 2, minus 1. Third row will be 0, 0, 1, minus 7 by 4. And fourth row will be 0, 0, 8, minus 6. Now the leading one you have in third row, so entry below the leading one must be 0. For that we are going to use R4 minus 8 R3. And that will give 1, 2, minus 3, 1. 0, 1, 2, minus 1. 0, 0, 1, minus 7 by 4. And the last row will be 0, 0, 0, 8. Okay. Now once you have this entry 8, so what we are going to do is, we are going to simplify this term. Now dividing last row with 8, that will give you the 1. Now this is your row echelon form. Okay. Check out, this is your row echelon form because each entry has a leading element 1, the leading one in the lower row to the further to the right than the upper row, and 0 rows are not there. That means all conditions are satisfied of row echelon. But for reduced row echelon, all entries above and below leading one are 0. So now we are starting with the last row and we are going to make all entries above the last row must be 0 in a leading element. So R1 minus R4, R2 plus R4 and R3 plus 7 by 4 R4. The matrix you have is a 1, 2, minus 3, 0, 0, 1, 2, 0, 0, 0, 1, 0 and last one is a 0, 0, 0, 1. And same manner, now using third row, we are going to make the entries above third row is equal to 0. And that for that we are going to use operation R1 plus 3 R2, R3 and R2 minus 2 R3. And that will give you 1, 2, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. Sorry, 0, 0, 1, 0 and last row is 0, 0, 0, 1. And again, using second row, we are going to make the second entry of first row is equal to 0. That means R2 minus 2, R1 minus 2 R2 and that will give 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0 and 0, 0, 0, 1. And this is your required reduced row echelon form. Okay. So these are some practice example which you have to do yourself. Okay. And if you have any doubt or any query regarding this topic, then please feel free to contact me. Thank you.